Welcome to the next video in the Suggestion App course. This is a complete course where we'll build a .NET 6 Blazor server application with MongoDB from the ground up. There are three things you need to know before we get started. First, this is part of a series, and this isn't the first video in the series. If you're just starting out, you should check out the playlist that's linked in the description to start from the first video in the series. Second, this course is actually a paid course. MongoDB sponsored it so you can put the videos on YouTube for free. Check out the link in the description to sign up for MongoDB Atlas for free to thank them if you haven't already. Third, you can also buy this course on imtimcorey.com. The link is in the description. Buying this course will get you all the lessons right away, the source code for each lesson, a certificate of completion, offline access, and more. It also helps sponsor more free content. The video will be the same as it is on YouTube, so feel free to watch the free version if you want to. Okay, let's jump into today's video. Note there may be more than one lesson in this video, since some lessons are short. Now let's move on to creating our actual data access. But before we do need to do one last thing to this DB connection, and that is to hit Control Dot to bring up the quick actions refactoring. And you want to extract an interface from this. We want this to be an IDB connection with everything selected. We hit OK. This creates our interface for us. What this will allow us to do is it will allow us to reference this when we create our next data access class. So let's right click on data access and say add class. Let's call this MongoUserData. I'm going to say Mongo in front of all these because of the fact that we could switch this up at some point to a different NoSQL database type, and it would work just fine. We just need to swap out the Mongo specific code for the specific code of whatever data access or database type we use. So whether or not we're ever going to do this, we're not. We're never going to change this, but in case we wanted to, this allows us to do that, and it doesn't hurt anything. It also makes sure that we create everything in a loosely coupled manner. So while I don't encourage you to swap out your data access code all the time or swap your database types, I do encourage you to create it as if you were going to, because that encourages you to create loosely coupled data access. So MongoUserData, and we'll get rid of our using statements. And we'll make this public. And inside here, what we're going to do is we're going to create a constructor. And we're going to ask for that IDB connection. We'll call it DB for database. Control Dot to create and assign the field. So now we have this underscore DB. We probably actually won't need this. So let's do this. Let's not create it. We're just going to bring it in with the connection, and that's it, or the constructor, and that's it. We won't actually use it except in the constructor. So private read-only though, MongoCollection, and this is going to be the type user model, and we'll call it underscore users. Let's do a Control Dot here. We need the using MongoDB.driver, but we're going to need this for every class that we create. So therefore, let's go to global usings and say global using MongoDB.driver. And that will make our life a little easier there. We'll have less using statements. So why are we doing this? Well, because we're going to ask the DB connection for the users. So underscore users equals DB dot user collection, not user collection name, but it's going to be the user collection. Like so. And that's just a get. And it's not a method, that's why it's yelling at me. It's just user collection. So we're going to grab the user collection, which is an already instantiated iMongo collection of user model. That's what we want. That's our users. We're just going to grab that and put it here. Now, if you're not familiar, when you copy something like this, you're not making a copy of the actual object. You are making a copy of the reference to the object. So therefore, we're not using any extra memory by making this copy here. We could just say db.userCollection everywhere, but by making this copy, this shortcut to underscore users, that makes it easier to reference and use throughout our project. So that's what we're going to do. So now in here, we're going to need a few different methods for users. You may find that you write the methods that you need and then come back and add more or modify the ones you have as you go. Since I have gone through this design process once already, I've probably worked out most, if not all, of the methods we're going to need. So let's go through them. So public async. We're going to try to do everything asynchronous as possible. This will be a task of a list of user model. We'll say GetAllUsers async. And in here, we're going to say var results equals await users dot, not GetAllUsers. We're going to say find async. We have to pass in a function here. So we're going to say, wow, there we go, our arrow, and just true. What this does, if you're not familiar with MongoDB, is this says, give me all the records, find them all, where discard character, meaning we don't care about the variable, equals true. So, I'm sorry, not where this equals true, but where true. So, what's going to do is going to look through every record and say, hey, is true true? And you're going to say, well, yeah, of course it's true. Therefore, I return that record. Next record, and so on. So this returns essentially all records. That's what it's going to do, and that's how we do a find all. If we wanted to have essentially a where clause, where we limit the scope of what we return, we'd do that here, where we'd actually give us a variable name like X or Y or U for user or whatever, and then say U dot, first name equals or something like that. But in this case, everything. So we're awaiting that. Therefore, we can return results dot first or default. So this is, results, that's the next one, dot to list. There we go. That returns all of the entries. So we're asking for all of the users in the list. This is not something we use normally. In fact, I believe the only time we use this is in our demo code for making sure we are properly talking to the MongoDB database. So just note that we're not going to use that very often, but this allows us to get all the users asynchronously. Next up, what we're going to do is get one user. So public async task of user model. And we're going to say GetUser string ID, passing in their identifier. And we're going to say var results equals await underscore users dot find async. And this time we're going to pass in, say, u arrow u.id equals ID. So we're going to look up based upon their MongoDB identifier. And then we'll return the first or default. So this one actually does a filter, the where, and this is a very specific one where it says, hey, match the ID to the ID you just passed in. Therefore, it'll only return one. And just to be sure, we return first or default. Next up is a very, very similar one where we're going to do the same exact thing. Let's copy and paste this actually. But we're going to say GetUserFromAuthentication. And instead of ID, we're going to pass in the object ID. Just to be clear here, that we're not doing the lookup on the ID, but on the object identifier. and that's going to match this object ID. What this is for is this is the object identifier that the Azure Active Directory B2C has given our user. And we're going to look the user up based upon that identifier. So when a user logs in, we're going to have an identifier. We're going to look them up by that identifier to get all their information from our system. Now, we're going to write all this DataAccess code, and then we're going to go test it, just so you know. So we're going to write all this code, and then go right to Blazor and create a demo page, which will allow us to hook things up, and it will allow us to test these things, and it will allow us to initialize our database. So we'll get there in a little bit. The next step we have is the CreateUser. So we have the public task CreateUser, pass in a user model, and we're going to say return users insert one async, and that's it. That's the entire process of creating a new user. And then we'll have one more, and this is public task update user, user model user, and here we'll say var filter equals builders user model dot filter dot equals and ID and user.id. So what this will do is it's going to create a filter for our replace. So this filter right here says, hey, I want you to match the ID to the user.id. This is what we're going to match on. Now we can say return users.replace one async and say pass in the filter user, and then new replace options is upsert equals true. Okay, like so. Let's unpin this so you can see the whole thing. So this is going to do a replace one async. So it's going to take the filter and say, hey, find this object, and I want you to put this object in its place. Now, those IDs have to match for you to replace. So we're already matching them on this ID. Therefore, they will match. We're going to replace the one it finds with this new one. And yes, we're going to do an upsert, which means that if it found no entry for that user, it would actually do an insert. But if it finds one, it's going to do an update. So that's a full replace of the object. And that should be all we need to do for our users. So the last step here is to do a control dot on our, when we have our class selected, and say extract interface. Now for this one, what I'm going to do is I'm not going to name it MongoUserData. I'll call it IUserData. That way, if I have, let's say Cosmos DB data, well, I have Cosmos DB user data, but then I'd still use the same IUserData interface for my different method calls. So that's why I'm going to trim down that name. We hit OK, and now I can use this in dependency injection. And note, this is coming from dependency injection as well. And yes, these are in the class library. Sometimes that confuses people. Yes, your class library can use dependency injection. It really should use dependency injection. So we're going to be doing that for sure. So that's all there is to the MongoUserData class. We have the GetAllUsers async, GetUser, GetUserFromAuthentication, CreateUser, and UpdateUser. So these are the ones we're going to be working with. Now let's move on to the next class. Now let's move on to the next one, which is going to be our category data. So right click on DataAccess, add new class, and we'll call this our MongoCategoryData. Make it public, get rid of our using statements. And then in here, we're going to create a constructor. And we're going to ask for two things from dependency injection. One is an IDBConnection called DB. The other is iMemoryCache. Let's do a control dot here to add that using statement. And we'll call this memory cache. Let's just call this cache instead of memory cache. Now, we're going to use caching in the category data and actually in the other data access as well, because of the fact that this is data that's not going to change that often. So we're going to definitely want to cache this for a long time. So let's first of all do a control dot on cache and say create and assign a field for that called cache _ cache. We'll also do a private read only, and this is going to be a iMongo collection of type category model, and we'll call it _categories. And then we can say that we're going to use the _categories equals db.category collection, like so. And again, that grabs that collection, makes it a little shorter and easier to recognize and use. Now let's start with gathering all of our different methods we're going to need. The first one is public async task of a list of category model. And we'll say GetAllCategories. So GetAllCategories. And I don't need to put async on the end of this. We're going to make all of these async. So therefore, if they're all async, you don't need to say async. Otherwise, it's just an additional bit of non-needed text. It's really only if you have a mix of async and non-async methods that you would call end one with the extension async. So GetAllCategories. Now, this is going to use caching. So the first thing I want to do is I need to use a cache name up here that I know about. So let's come back up here at the top, and we'll say private const string cache name equals category data. This is the name we'll use for our caching for this category, or this category data. So now we can say down here, var output equals cache.get. This is going to be a list of category model. Cache name. So it's going to ask the cache for this cache data, category data it's called. So this cache by key, that's the key, is cache name. So we're going to say, hey, do you have category data? If so, it should be a list of category model. Now, if we do, we'll just say return output. And that's it. Because that's all we need to do. We've got it from the cache. However, it's not going to cache the first time. So therefore, if output is null, we're going to say var results equals await categories. And it's not .getAll, it's find async. And we're going to again say, just give me everything, like so. Output equals result to list. But we're not done yet. This is where I get tripped up every once in a while. I forget to do this, and then I wonder why my cache does not perform well, because I never cache it. Okay, so if the output was null, that means it did not find it in the cache. Therefore, we have to put this data in the cache. Therefore, cache.set will pass in the cache name and the output. I also want to give it a time span from days 1. What this will do is it's going to use this cache key, which again is our category data string. We're going to put the value in of the output, the list we just got. We're going to say, keep that in the cache for 1 day. So every day, and not before, but every day, we're going to get a new list of categories, just once. After that, we're not going to get it again. Now, I have had people ask me the question, so what happens if multiple people do this process, don't get the cache, like it's not in cache, and so they start this process of getting the categories, and while they're still getting the categories, somebody else checks the cache, and they get the categories. And maybe you have 5 people do it, and they all actually go to the actual database, get the list of categories, and they all set the cache. And the answer is, who cares? I know it sounds weird, but unless you're at the spot where it's a really big deal, you don't have to care. Because if we weren't doing caching at all, then we would be doing these 2 lines every single time. So that's what we'd have normally. And that's what would happen if we have multiple people try to get the cache at the exact same time. So they're all going to hit at that exact same time. They're all going to get the data from a database. But then the last one, they're going to keep overwriting their own values over and over and over again, setting this cache with essentially the same data. And at the end of it, we're going to have it cached. And then it won't be accessed again for a full day. So you may have 5 people that, and you probably won't, but even if you had 5 people that read from the database at 8 o'clock in the morning, that would happen 1 time during the day. So you have 5 calls to the database instead of a few thousand throughout the day. So your caching is still working. It's not going to hurt anything. If making those 5 calls is a massive deal, first of all, you need to check to see if caching is the right call anyway, because if the data is going to change every time you make a call, that's not cacheable data. But if it's just really expensive to make this call, yes, there are things you can do to ensure you only ever make this call once. So there's some, I think it's called lazy cache or something like that, you can wrap around the memory cache that will allow you to make sure that you lock things down to only ever getting one value or one call to this. Essentially, all it'll do is it will put people in line and say, okay, if the first person got to this point, then everybody else has to wait until they're done this process. And then everyone else can go and get the cache and get the cache value. So that's all it's going to do. That's all you can do, is make everyone else wait. So that's what it'll be a minor wait. It'll be only as long as this call is, which they have to wait anyway. Therefore, not a big deal. So that's what you can do if you need to. We don't need to. This is perfectly fine for our needs. So this list, this getAll, is going to give me a list that I'm going to show on that main page where we have a list of categories. That's what I need, is the GetAllCategories. Therefore, we're going to cache it so that we only ever get that list once from a database, and after that, we'll get it from the cache. The only other thing I need here is public task create category. Category model, category, and in here return categories dot insert one async category. Again, this will be mostly on our setup page where we have a process will run once per database. So we will very rarely run this. We'll only run this when we move to a new database, but this will reestablish all of our categories. So we'll have a process that creates all of our categories, and maybe at some point we'll add the ability for a modification to the system through the front end to add new categories. But we probably won't do that. We'll definitely not do it in version 1, but it'll be a ways before we do that. But it's set up for it now, and we can use this for setting up our initial database. So that's all we need for categories. Mostly just read them, but we do want to have the ability also to create them. Okay, that's it for the category data. So we can put our mouse cursor back on the class MongoCategoryData, hit Control Dot to bring up the quick actions and refactorings, extract our interface. We want to change that name, remove the Mongo, so it's ICategoryData, and hit OK. And that's all we have to do for that class. This next DataAccess class is pretty much the same as category data. Right-click on our folder. We're going to say Add Class, and this is going to be the MongoStatusData. So this is our status data as opposed to our category data. Get rid of our usings. Make this public. And we're going to create let's create our private read-only iMongo collection. And this is of type status model. And we'll call this, let's call it statuses. And then we'll create our constructor. And this constructor, we're going to pass in both the IDBConnection, called DB, and also the iMemory cache, called cache. And we'll add that using statement. Now, I have added a using statement twice. I'll add it one more time. I'm not sure that qualifies for need to go into global usings. I think we can just add the using statement. Using statements are not bad. You can put them on top of classes. It's okay. It's just we don't want to have tons of them that are just invalid. You keep seeing me delete a whole bunch of using statements. That's what we used to have to deal with. Now we don't have to do that as much, having all those using statements at the top that are all messy. So it's okay to have some, but if you find yourself repeating over and over again, that's when you can move it over into the global usings as long as it does not cause a naming conflict. So with the memory cache, we do want to add this, do Control Dot here, add that private read-only field, and then we also do want to have a private const string. We call this cache name. We're going to call the same thing in this one as well. So status data. So this is the same as what we had in the category data where we had this cache name. We'll call the same exact thing because it's the same thing. It's the cache name for this class. Therefore, the name itself, the string is different, but the variable name will be the same. So now we have statuses equals db dot, and this is status is collection. And so now we have this populated as well. So now we can start creating our two methods. That's all we're going to need. The first method is going to be public async. This is going to be a task of type list of status model. And we'll say GetAllStatuses. And we're going to say var output equals cache dot get a list of status model cache name. So we're going to ask that cache or return the output. I call it output because that's what tells me that this is the variable that gets returned. If I call it something else, it's not as obvious that that's what gets returned. So by calling it output, since I have multiple variables, it's just very clear what is getting returned from this method. So if output is null, meaning you didn't find it in cache, var results equals await statuses dot find async, or again, give me everything like so, and then output equals results to list. And again, do not forget cache.set cache name and output. And again, we're going to set the time span to be from days 1. And then just make sure that we're going to have this stored in the cache for a full day. And then again, we have one more public task, CreateStatuses, or CreateStatus, status model. And we'll return statuses.insert one async status. So again, this will be used sparingly only in our initialization of our database and in any testing we do, but otherwise we will not use this method for anything else. So that's it. Just like our categories, our statuses are pretty straightforward and easy. So now we can hit Control dot on our class name, extract the interface. We'll make sure we take off Mongo, and we hit OK to create that interface. And that's all we have to do for the MongoStatusData access.